Welcome to this SkillPad video resource, where we make learning fun. In this video we are going to look at the phenomena of heat quantities and vapors. Have you ever pondered why it takes so long to boil a pot of water, or why ice takes its sweet time melting on a hot summer day? The answer lies in the fascinating world of heat quantities and vapor, two concepts that are intimately intertwined with our everyday lives. Let's start by understanding heat capacity. Think of heat capacity as a sponge, but instead of soaking up water, it absorbs heat. It's the amount of heat needed to increase an object's temperature by a single degree Celsius. So if an object has a high heat capacity, it can absorb a lot of heat before its temperature noticeably rises. Now, imagine pouring a few liters of boiling water into a bathtub. The water in the tub warms up, but the tub itself remains relatively cool. This is because water has a high specific heat capacity, meaning it can absorb a lot of heat without a significant increase in temperature. This property is why our oceans maintain a relatively stable temperature, acting as a buffer against drastic climate changes. Let's now delve into the realm of latent heat. This is the heat absorbed or released when a substance changes its state, like when water turns into ice or steam. This heat doesn't change the temperature but alters the state of the substance. There are two types of latent heat: the latent heat of fusion and the latent heat of vaporization. The former is the heat needed to change a substance from a solid to a liquid, like melting ice into water. The latter is the heat required to change a liquid into a gas, like changing water into steam. You might wonder why the specific latent heat of vaporization of a substance is always greater than its latent heat of fusion. This is because breaking the intermolecular bonds in a liquid to convert it into a gas requires more energy than changing a solid into a liquid. Now let's talk about vapor. When a substance is in its gaseous state, we often refer to it as vapor. There are two types: saturated and unsaturated. Saturated vapor is like a sponge that can't absorb any more water, while unsaturated vapor can still take in more. This brings us to the concept of saturated vapor pressure, which is the pressure exerted by a vapor at the point when the rate of evaporation equals that of condensation. This concept, often referred to as thermal equilibrium, helps explain why water boils faster at higher altitudes, where the atmospheric pressure is lower. For at such higher altitudes, heated water quickly reaches the point of thermal equilibrium, where there is no more heat transfer into or out of it. The boiling and freezing points of substances are also influenced by other factors like impurities and pressure. For instance, adding salt to water lowers its freezing point and raises its boiling point. This is why we salt icy roads in winter or add salt to pasta water. The concept of regulation, where pressure can cause a substance to melt and refreeze, is applied in pressure cookers. Here, the increased pressure raises the boiling point of water, cooking food faster. Lastly, let's appreciate the cooling effect of evaporation. When sweat evaporates from your skin, it absorbs heat, cooling you down. This principle is harnessed in air conditioners and refrigerators. In conclusion, understanding heat quantities and vapor allows us to appreciate the world around us. It explains why water boils at a certain temperature, why ice melts, and even why we feel cool when we sweat. It's a fascinating journey into the world of physics, one that illuminates the magic in the mundane. Thank you for using this SkillPad video resource. We hope it was enchanting. Come with us as we explore the world of science for your learning pleasure. We hope to see you again soon.